Poynting vector. Actually, the basic idea of a Poynting vector is it gives a relation of power. It gives a we can study about power of a electromagnetic wave with the help of this Poynting vector. Simply, what is Poynting vector is, suppose if you consider a volume, this is some volume in free space. The total power leaving the volume, this is a free space. I am considering a small volume in free space. The total power leaving the volume is equal to rate of decrease in energy. Rate of decrease in energy stored in electric and magnetic fields minus ohmic power dissipated. Ohmic power dissipated. This is nothing but rate of decrease in energy stored in electric and magnetic fields. So the total power leaving this volume is nothing but the power leaving or the power due to electric and magnetic fields only. Here what is this thing? Rate of decrease in energy stored in electric and magnetic fields. Rate of decrease in energy is nothing but power. So the decrease in power due to electric and magnetic fields. And ohmic power dissipated. This is nothing but losses. Due to some losses. The best example is, suppose if you take a hot coffee or a hot tea in a cup, like this. So the rate of heat decreasing from upper side, and some losses due to this vessel. Losses due to this vessel surface. Okay. So we can compare with this example. So the total power or total energy leaving is nothing but total power going from upper side and some losses due to the vessel surface. Similarly, the same concept here, the total power leaving in the volume is nothing but rate of decrease in energy stored in electric and magnetic fields minus some ohmic power dissipated. Nothing but some losses. Poynting, this is called Poynting theorem. Poynting theorem. Suppose here I am not going for the derivation of the Poynting theorem. The main concept of Poynting theorem is nothing but it gives about power of a electromagnetic wave. Power of a electromagnetic wave. The Poynting vector is given by P is equal to E cross H. P is equal to E cross H. Generally we know that the power is equal to VI, voltage into current. What is electric field? Electric field is nothing but what is voltage? Voltage is nothing but integrated effect of electric fields. What is current? Current is nothing but integrated effect of magnetic fields. So same concept here also, but here we are applying with a cross. It has some vector, it is some vector quantity. And the average power is given by, power average is equal to, we have two relations, one is half into real of E cross H star, this is one relation, and another relation is the average power is given by half into E square by eta some an cap. An cap. Here also it is here it is the average power is an cap. What is this an cap is propagating direction, wave propagating direction, wave propagating direction. That is, the Poynting vector always in the direction of wave propagation. The Poynting vector always in the direction of the wave propagating direction. So these two formulas are very useful for solving problems. We will solve one example problem. The problem is like this. In a non-magnetic medium, E is equal to 4 into sine 2 pi into 10 power 70 minus 0.8 x Az cap volt per meter. Calculate. First one is epsilon r and eta. Option B. The second question is time average power. Time average power carried by the wave. Time average power carried by the wave. The solution to this problem is we have to first calculate epsilon r. Here beta is equal to 0.8 sin omega t minus beta x, general formula. So beta is equal to 0.8. Omega is given 2 pi into 10 power 7. We know that beta is equal to omega by C. Beta is equal to omega by C. If you observe that here C is velocity in free space. C is a velocity in free space. But here it is given a non-magnetic medium. So it has some epsilon r value also. So it is not C, it is C dash. Here C dash is equal to C by square root of mu r epsilon r. Non-magnetic medium, mu r is equal to 1. Therefore, beta is equal to omega by C into square root of epsilon r. Therefore, square root of epsilon r is equal to beta C by omega. What is beta? Beta value is 0.8 into C, 3 into 10 power 8. 3 into 10 power 8 divided by omega 2 pi into 10 power 7. Simplify this. If you simplify this, we will get square root of epsilon r as 12 by pi. Implies epsilon r is equal to 144 by pi. 144 by pi. This is epsilon r value. Next one is eta value. Eta value is nothing but square root of mu by epsilon. So this is nothing but square root of mu naught mu r. Mu r is 1 by epsilon naught epsilon r. That is equal to square root of mu naught by epsilon naught by square root of epsilon naught. This is 120 pi by square root of epsilon r. Square root of epsilon is 12 by pi. So this is nothing but 10 pi square. This is 10 pi square. So eta value is calculated. And third one is, second question is time average power. So I have to calculate average power. I have two formulas. One is half into real of E cross H star. Other one is half into E square by eta, A n cap. Because here it is only given one equation, that is only E is given. So just you go for the second formula, that is half into E square by eta, where E is an amplitude part, only amplitude part. So this is equal to half into E square. What is the amplitude? 4 square. 16 by eta. Eta is 10 pi square. What is A n cap? This is actually A n cap. A n cap means propagation direction. What is the propagation direction? Since the wave is given E is equal to omega t minus beta x form. So the wave is propagating in positive z direction. So we will get ax cap. We will get ax cap. So if you simplify this, how much you will get? 16 by 2 into 10 pi square ax cap. If you simplify this, approximately you will get 81 ax cap milliwatt per meter square. Milliwatt per meter square. Here the unit is power is what is the unit? Watts per meter square. We are calculating through a area, average power. Average power is nothing but through a unit area. So that's why the unit is watt per meter square. So generally we can expect this type of questions. Here we have to calculate eta, so which is related with the average power. So there is a possibility of getting linked questions based on this concept. Next problem is based on Poynting vector only. The problem is problem number 2, of course. Electric field is given by Ax plus j Ay e power j kz minus j omega t. H bar is given by k by omega mu ay cap plus j ax cap into e power j kz minus j omega t. The time average Poynting vector is the time averaged Poynting vector is option A null vector, option B k by omega mu az cap, option C 2k by omega mu az cap, option D k by 2 omega mu az cap. The solution to this problem is, one thing is very clear. If you observe the equations, both E and H bar is given. So if you take j common, there is e power j kz. So e power j kz. E power j kz means the wave is propagating in positive z direction. Or if you take common minus j, so omega t minus kz form. So obviously the wave is propagating in positive z direction. So that we can expect the az components. So if you observe the answers, az is here, az. Here one thing is specially it is given null vector. Because here the two equations are given, we will go for this formula, the average power. We have to calculate average power. The average power is given by half into real of E cross H star. E cross H star. We will go with this formula because both E and H are given. H is given by K by omega mu Ay plus Jax e power j kz minus j omega t. H star is given by K by omega mu Ay minus j Ax. If you take here e power minus j common means omega t minus beta z. That is, now it becomes plus. So this is nothing but becomes e power j omega t minus j kz H star. So the average power is half into E cross H star. Therefore, average power is given by half into real value of because here amplitude is K by omega mu, that is common. Ax bar plus Jay e power j kz minus j omega t cross Ay minus j Ax e power j kz plus e power j omega t minus j kz. Amplitude is K by omega mu. So K by 2 omega mu. Calculate what is this cross of this. Here it is j omega t, not j kz. J omega t minus j kz. So Ax cross Ay. Ax cross Ay. Ax cross Ay means Az. Az bar cross Ay multiplied with these two things, e power j kz minus j omega t, e power j omega t minus e power j kz. So e power j omega t, e power minus j omega t cancels, e power j kz, e power minus j kz, e power 0. So the resultant is 1 only. So the first multiplication factor is Az only, plus Ax cross Ax is 0. So no need to go for that. Similarly, Ay cross Ay is equal to 0. So no need to go for that. Now Jay cross minus Jax cross. J into J square. That is J square is minus 1. So the resultant minus of minus plus Ay cross Ax. Ay cross Ax. That is nothing but minus Az. Similarly, this e power j kz minus j omega t multiplication of this e power 0. So that is 1. So this is nothing but what? 0, which is a null vector. So the average power is 0. So it is a null vector. So option A is correct. Option A is correct. So you must be very careful when you are solving this type of problem. Next problem is problem number 3. The time average Poynting vector in watt per meter square for a wave with E bar is equal to 24 into e power j omega t plus beta z ay cap volt per meter in free space is option A minus 2.4 by pi az cap. Option B is 2.4 by pi az cap. Option C 4.8 by pi az cap. Option D minus 4.8 by pi az cap. The solution to this problem is very simple. Here it is only given one equation, E bar is equal to 24 into e power j omega t plus beta z ay cap. So the average power, directly I am going with the formula half into e square by eta. Here it is given free space. This is e square. It is given free space. Free space eta is equal to how much? 120 pi. Because here all the options are given in terms of pi. So go for 120 pi. Don't go for 377 ohms. 377 ohms. 120 pi. So that is equal to half into magnitude is 24 into 24 by 120 pi. So it's nothing but what? 2.4 by pi. An cap. What is An cap? An cap is nothing but propagation direction. So here the wave is given omega t plus beta z form. Omega t plus beta z form. Omega t plus beta z means the wave is propagating in minus z direction. Minus z direction. Therefore An is nothing but minus az. An cap is nothing but minus az. Therefore average power is equal to minus 2.4 by pi az cap. So option A is correct. Option A is correct. This negative sign is because of the negative sign is not the amplitude sign. The wave is in here. The negative means the wave is traveling in negative z direction. Negative z direction. So just you can eliminate two options because here it is given omega t plus beta z. So definitely we have minus az cap. We don't get amplitude as negative. So definitely we can eliminate option B and C. Option B and C. So the answer must be either A or D. So calculate accordingly so that you can get very easily. So here the conclusion is if only one wave equation is given, that is either E or H, then for calculating average power use the formula E square by 2 eta. Suppose both E and H are given, then to calculate average power use the formula half into real of E cross